Hey, what's up guys, my name is Cherno and welcome to another episode of Game Programming, episode 106. Let's go ahead and talk about debugging displays and all of that stuff because there's a lot of really cool things that we can do with that. And I'm going to show you one thing that we can do with that here. Okay, so I've got the Sprite class open here, as you can probably tell, and that's because I want to kind of touch on this because we've kind of done, let's just say half. It's not really anywhere close, but let's just say we've done half of this debugging method already, and I want to just point that out so that you guys don't get too confused. We've got a way over here to create a sprite that is simply a size and a color, right? And then obviously that's to create a square one, and then this is to create one that isn't square. You can obviously use it to create a square method, rather a square sprite, but it's got a width and height, it's got separate parameters, and this basically just allows us to create a sprite with these details, right? Okay, and the reason that that's actually useful to us is because we can kind of render it anywhere. And as we do go ahead and render that, you'll see that in our screen class, which is over here in the graphics place right over here, in our screen class we have render sprite, and we have this option, this boolean fixed, okay? And if something is fixed, that means it is actually tied to the level, which means that its coordinates, its position, its location is relative to the level, not to the screen, not to the monitor, not to the window, the actual Windows 7 window in this case. It's not relative to that. Fixed means it's actually relative to the level, which means it will move with the player, kind of. Like, as in it'll move, yeah, it'll move with the player, like it'll move according to where the player is. Now, that's great, okay, and that's one way to do it, but sometimes we just want to quickly throw something up there that isn't necessarily sprite, right? This stuff is meant, this method, render sprite, and this constructor to make a sprite this way is meant for actual game elements, not debugging elements. And the reason is we obviously need a new sprite object, and the word sprite, you can tell, isn't really supposed to be used with debugging. In fact, sprite is probably something we would debug. So I want to talk to you guys a bit about that today. But what I want to show you guys right now is how Sprite kind of works, okay? So if I go ahead and go into, I just want to go into spawn level really quickly and see what our coordinates roughly are. Our tiles are 16 by 16, I believe. I always forget this. Yeah, well, it says tile size 16, so I'm just going to assume that's accurate. But the idea is that, okay, so our dummy is at like maybe 1553. Okay, that's cool. So I'm gonna go ahead and go into the shooter class here, and in the shooter class under render, what I'm gonna do is I'm gonna go ahead and say new sprite. I'm gonna create a sprite that's 80 by 80, and it's gonna be what are the parameters? The color. Okay, let's just make it red. Okay, red. Okay, I'm gonna create a new sprite here, and I'm gonna render it straight away. Or rather, the way that we would render it, of course, is by calling screen.render sprite the x and y position. So we'll make the x and y. We'll make this. Let's go ahead and just for now make it 80 by 80 as well. And then the sprite, of course, will be here, and the fixed will be false. Okay, so it'll kind of float. If I can even type today, there you go, float. Okay. Let's go ahead and make sure that this is outside of the constructor, of course. Add another bracket in, that should be good. Alright, let's go ahead and see what that looks like. So what we should see is this massive red rectangle, and you can see it kind of follows, it moves with the player, as in like it doesn't move relative to where the player is, it's relative to the screen, okay? And it's actually rendering under the projectiles and stuff, but over the mobs, so that's interesting as well. But that's kind of what we're going to do here. If we do set it equal to true, of course, and you guys know this, I'm just kind of reiterating what we all already know, just so that you guys can get it a bit cleaner. And obviously it's been a while since we've done that. But let's go ahead and change this to maybe, I think it's like 53 times 16 by, or was that's probably the y, isn't it? I'm going to go back to spawn level. Yeah, so 53 is the y, and then like 17 is the x, fixed as true. So what we should see here is, if I move down here, we can see that now we now have this red thing that stays there. Yeah, it stays there. It stays with the level. Okay. So we're kind of gonna do something like that, but it's gonna be made with a debugging kind of point of view, and for the debugging I guess use, right? This screen.render sprite method, and we create a new sprite object here. This stuff is meant for actual game elements. Now let's talk about making a kind of debugging element, okay? So under util, okay, I'm going to put it into util. I'm going to go new class, and I'm going to call it, very, very simply, debug, okay? That's it, debug. Come on, debug. There we go. And right now, this is going to be a static class, all right? So it's not going to have any. In fact, let's just make sure we enforce the fact that it's static by making the constructor private. But yeah, this is going to be a static class, okay? So this is never supposed to be instantiated ever. Public static void draw rect, okay? That stands for draw rectangle. I'm sorry about that noise outside, by the way. I can hear someone like hammering away at something. Draw rect, okay? And all that we really need for draw rect is obviously we need a way to draw it. So we definitely need an instance of the screen class, yeah? And then we also need the X and Y position, so in X, in Y, as well as the width and the height. And we probably need whether it's fixed or not, right? Great, okay? So what we've done here is we've kind of given ourselves, I don't know if I want to put screen as the first parameter. Yeah, we'll go ahead and do that. We'll leave it like that. Make sure you import screen, of course, and this does not all fit, but basically, here we go. We have 6 lovely parameters here. We're going to go ahead and call a method in screen called screen.drawRect, okay? That'll obviously, that'll probably take X, Y, width, height, and fixed. So everything except for screen obviously doesn't need to take screen because it is screen. So we'll create that method in the screen class. So you can see here in the screen class, I am going to move it up a bit. We're going to make this method called drawRect. And now what we're going to do here is actually make sure that we draw a rectangle. Now this isn't like a fill rectangle thing, so it won't be filled, and that's the point actually. So I want to show you guys a quick algorithm that will very easily, let's change this to XP and YP, very easily draw a rectangle. So what is a rectangle? A rectangle is made up of 4 lines. If I go into paint.net, I'm sure I don't need to really explain this to you guys, but just in case, it'll give you a better understanding. Rectangle is 4 lines. So what we need to do is we need a starting point, and we need to draw a line just like that. Okay. We also need to do the same for Y. Okay. That's the first 2 steps of drawing a rectangle. So that's our goal right now, just to draw those 2 lines. Okay. A color would also be nice. I forgot completely about color. So let's go ahead and width, height. We'll probably put color in here. I'm going to spell it. I'm just going to call it col. I'll put it right after the height here. We can obviously make other methods here that will wrappers basically, so that we don't need to use all these parameters. But int color. Okay, great. So okay, so that's the first thing we need to do. So let's go ahead and type in for int y equals this y position here, because we want it to start at the y position, of course, and go until height. So if y for y is less than yp plus height, we will of course increment y here. We'll do the same for x, but make sure it's outside. That's another thing you have to realize, okay? They're not nested. They're not inside like that, okay? This is not a nested for loop. If we were filling a rectangle, yeah, it would be. But here it's not. Make sure that we use x here. Of course, XP. In fact, we might as well do X first because they're not nested, and it's not like, again, with the whole deal with doing Y first when it's nested. That's really just a convention, because when you're drawing scan lines, you're usually drawing them down Y, so you're drawing them horizontally, not vertically. That's just a bit of a convention. Here it doesn't matter because we're not filling anything in. So I am gonna go ahead and just shift X up here. You can keep it however you like. Great, so that looks pretty good to me, okay? Now all we're going to do is we're going to say pixels, X, let's see here, so this is, I think, okay, yeah, this is the X one. So we'll actually go ahead and say, X plus, I think it'll just be, okay, so we actually have to do XP plus X plus yp times width, and that'll actually be this dot width, and we'll set that equal to the color. Okay, great. And that's our X figured out. Sorry, I just kind of figured this out on the fly. Y will be sorry, the same here, except we'll actually use XP instead, which by the way refers to the position, right, not our for loop. And then we'll change this to be Y plus YP. All right. Great. Now this thing has to be enclosed in brackets because otherwise we're evaluating YP times width and then adding Y on. We want to evaluate that and then apply it. Yeah, but that looks pretty good to me. And this dot width, of course, stays for both of them because that is the width of the array. So let's go ahead and try this out. Okay. We've got a basic method here. It sets it equal to a color. Now what it doesn't do, okay, it obviously just draws the 2, okay, and this is vastly in, like, it's not finished yet. But let's go ahead and nevertheless see what it looks like. I'm just going to close all these other classes that we don't need at all, just so we're dealing with what we need. And over here, I'm simply going to call debug, again with a debug.drawRectangle, so screen, XA and YA we'll just put to maybe like, again, 80, 80. Maybe not, maybe that's a lot, like 40, 40. We'll make the width here, we'll set that equal to maybe 100. We'll make the height like 40. We'll make the color pink, and fixed will be false. Won't matter yet. Okay, so let's go ahead and launch that and see what happens. Okay, so we kind of get we get an interesting little thing going on here. They don't seem to start at quite the right spot, but it is generally what we're looking for. So let's go back to the screen method, screen class real quick and see what's up. Okay, so obviously we're actually already calculating the offset here, so I'm not sure why I did that. But this just needs to be X, but this does need to be YP, all right? And it's going to be the same thing here. So this does not need a YP, rather just a Y, because Y is actually equal to YP, so I kind of messed that up. For some reason, I thought we were going from 0 to width like that, and you could do it that way as well, right? And then just calculate the offset, because that's how we do it every other time. But here it's just, we might as well start the for loop at the correct position here. Okay, so there's 2 ways of doing that. If we launch that now, we should see it perfectly done. Okay, sweet. So that is what we're dealing with right here. Now the other thing that you need to realize is that that's half a rectangle, right? We need to draw these 2. Okay, so how do we do that? Well, luckily it's really easy and it doesn't really require much. Okay, all we have to do is draw the exact same thing again, but offset it. So this is the X one, which means that it's the horizontal one that we're looking at. We need to simply render it again at plus height. Okay, so let's just render that, see what that looks like. Okay, great. So we've got this side now, and then the final side is going to be the same here, right? So we're simply going to actually add width, and we don't really need brackets around this, but we'll do that anyway, just so it looks nicer. And then you can see we've got an entire rectangle. This is awesome, great. So there's something up. There's actually 2 little problems. The first one, okay, is the fact that, and you guys won't actually see this right now because this isn't fixed at all, but we're not handling any kind of clipping, okay? So if I were to, for example, make the rectangle be outside the screen, so in Shooter, if I make it at like -40, then it's just gonna crash, okay? I'm just gonna launch it for, oh, okay, even better. It's not gonna crash. It's gonna do this ridiculous thing where it warps the screen, okay? Not good, okay? And the same thing applies if we make the width too large here, okay? It's, look, okay, it's not really working out, okay? And we need to figure that out, okay? We basically need to tell it that if you're outside the boundaries, don't render, okay? Because if it does, it will, in this case, it'll warp it, but sometimes, because we're handling this a bit better, but in other cases, it will simply crash with an array index out of bounds exception, okay? So really important stuff. So to fix that, we've done it before, basically. I'm just going to rush through this because it shouldn't really take that long, but if XP is greater than or equal to this dot width, make sure you don't use width, because width would be the width of the rectangle, whereas by this dot width, we're referring to the width of the actual screen, because this, of course, implies that it's referring to a field rather than simply a local variable or a parameter in this case. We'll also make sure that Y, now not YP, just Y, actually this should be down here obviously, Y being this Y here, is less than 0, okay, or Y is greater than or equal to this dot height, then we'll continue, which means that we'll skip that iteration of the for loop and we just basically won't ever render this. Same thing needs to happen for X. I'll just repeat this one step at a time for each of the things. All that needs to happen here is, because it's the first one, we just need to basically replicate this, but for X. So X is less than 0, right? Or X is greater than or equal to this dot width, right? Or Y, and YP actually is greater than or equal to this dot height. Now you guys might be like, what about YP less than 0? And don't forget that we're actually doing this kind of like twice, right? Because we're rendering these two different things. So if we handle everything up here, what's actually going to happen is, you know, this pixels, this one might be the one that's causing the problem. So this one might be the one that's actually out of, like, the top part of the rectangle, right? This top part here, it could be off the screen. Yeah. If we move this up here, for example, then you guys will see what I mean. This might be off the screen, but the bottom part's still fine. So we still want to render the bottom part. We just don't want to render the top part. But if we go ahead and handle it at once, then both the top and the bottom will actually disappear. Okay? So that's why we split this up. And we say simply that if y is greater than 0, then we render. So what we're saying here is we're saying that if, and by that I mean, keep freaking, okay, this should be X. So, no, that's still wrong. Hang on. What am I doing? So, if, if YP, okay, my bad. If YP is greater than 0, then we render it, okay? So what we're saying is that if YP is less than 0, do not render this, but still render this, okay? And that's what's kind of going to make us work here. We're basically just going to put the same thing for here. We're simply going to say that if X, P here is greater than 0, then render that, okay? Yeah, so let's go ahead and render that, and at the moment we get everything is good, but in Shooter, let's go ahead and adjust these indexes a bit. So we'll set this again to -40, and what you guys should see here is the fact that it's not warping or anything, it's just not rendering anything past that, okay? Now, there's actually another problem going on. It's hard to see, but you know what, I know I'm going to forget to zoom in while I'm editing this, so what I'm going to do here is, this isn't really going to work out like I wanted it to, but I'm using magnify here. Okay, there we go. You guys might be able to see that there's actually it's not rendering that last pixel there, okay? And that's got a really easy solution, okay? All we need to do is simply say that for either, I guess, X or Y, it doesn't really matter. We'll do it for Y. We'll set it to less than or equal to. So basically we're just saying draw one last pixel in there. And if I move this back into the screen, you guys will, where are we? You guys will be able to see that it works really well, and that covers that. Now, if you were being really picky, you might say that, oh well, then it's rendering 2 pixels, and it is, but you know, let's just be quiet about that. Because our other option would be to manually render it here. So we could go ahead and say, you know, like pixels XP plus width plus YP plus height times this dot width equals color, and do it outside of the for loops because it's just 1 pixel. But that would be just, you know, let's just not do that. Okay, good. So this is taking a while. It usually does, these episodes of game programming, but I'm just trying to explain everything as good as I can. Let's make one more method here. We'll make it public static void. It'll be draw rect again, but instead this time we'll just go ahead and omit the color. And so let's go here, get rid of color, and then we'll simply say we'll simply call the draw rect method here with everything except for color. We'll add probably red. We'll make red like the default color. Okay, and that'll just basically, and then make sure that that'll basically just allow us to, if we go into Shooter, that'll just allow us to draw a rectangle without specifying the color, and then if we do that, it'll just make it red, which it has done. Great. Okay, so one more thing we need to talk about is whether it's fixed or not, because if it's not fixed, yeah, okay, it's obviously that does absolutely nothing right now. So let's go ahead and change the coordinates quickly to be 17 times 16 by I think like 57 or something times 16. And we'll go into screen, okay? And in draw rectangle, we'll simply add the same clipping. In fact, I'll just copy and paste this just to emphasize it. This if fixed from render sprite, right? So this offsetting for the XP and YP, we will simply paste that in here, okay? And that is it, okay? That is if the fixed boolean is true, which it is in this case, because as you can see, we've specified it true here, okay? We'll launch that. Let's go down here. An array index out of bounds exception. Fun. Okay, so we actually forgot to handle the other side of this thing. We only handled like the top and the left, basically. So what we need to do also is fill out quickly here. If YP this time, right, plus height. So before we did the other thing, but here we're going to do if YP plus height is greater than equal this dot height. So what we've done before, and we'll just hit up continue. Let's just terminate this application. What we kind of did before here is we said if YP is greater than equal to this dot height, right? Then continue. But here we're saying if YP plus height, and the reason we're doing this is because if YP is actually greater than height, basically greater than or equal to height, then the entire rectangle would be, would not need to be rendered, or at least those two. Well, yeah, I guess. Well, at least those two, the top and bottom parts of the rectangle would not need to be rendered. But we still might want to render the bottom part. So basically, what I'm saying is, we couldn't put height up here because we still do want to render this, okay? Because that's the top part of the rectangle. And then we run a check for the bottom part of the rectangle to see if we can render that, okay? Because otherwise, if we put them both up there, what you'll see is both the top and bottom won't render. But we want one of them to render, because sometimes, of course, you have this situation where only the top is out of bounds, not the bottom. So we still want to be able to render the bottom, which is why we can't just simply continue, because that would skip both pixel rendering pieces of code. So I'll change this to XP plus width, this dot width. And now when we run it, we should not get any kind of array index out of bounds exception. If we just go all the way down here, you can see that we've got this red rectangle here, and it looks pretty good. I mean, it doesn't, like, as you can see, clipping works pretty well here. Just as I say that, it crashes. And the reason that it crashed, of course, is because XP here is equal to -81. It is over here as well, but here you can see that we actually only render that if XP is greater than 0. So if it's not, let's bring it back here. Make sure that we don't render that part. Now it's a bit different over here. You can see that here it's YP, not XP, okay? So then if we save this really quickly, I'll just quickly make sure that that does work. And if it does, which it of course should at this point, if I just go down here, okay, there we go. That looks pretty good. Now you can see what I was talking about with the clipping though. If I go out like that, if that thing is not in bounds, that disappears, okay? And that's why I want you guys to know that the solution isn't as simple as XP is greater than 0, okay? It actually needs to be XP plus width, okay? Greater than 0. Same thing over here to plus height, okay? And then if I go ahead and I save this and go back to it, you guys should see that it does actually render. So that's what I wanted to just visually show you guys what the difference would be, because you can't get away with just saying, one if statement with a continue. That's not going to work in this case, because we're actually rendering two different arrays of pixels, okay? We're rendering one for basically on each axis, one for each, I guess, edge, right? Top and bottom, and left and right, okay? Anyway, that's going to wrap up this episode. I hope you guys did enjoy it. The reason I actually did this entire thing was because we're going to probably talk about mob boundaries and making sure that mobs actually stay within their boundaries next episode. And the reason that's really important, of course, is we don't want mobs in our game to wander off anyway. So in other words, if I put a mob at this particular paddock, I don't want him to be able to get out. And, putting just a collision mesh is not good enough. We want to kind of just contain him within a box. And it's going to be pretty hard to visually see that box, which is why with tools such as this debug class, and I know that this episode took probably longer than it should, a lot longer than it should, but I just wanted to make sure I was getting my point across. And the point, once again, is the fact that this kind of stuff will ensure that we can visually represent certain things, like certain boundaries, onto our screen, okay? And we'll probably add more debug tools as we go along. But that's it. Hope you guys enjoyed this episode of Game Programming. If you did, please hit the like button. And don't forget that, of course, if you guys want to have a private tutorial with me, then you can certainly book one over here on my website, thecherno.com/tutoring. The link is in the description. Simply pick an available time, fill in the form with that available time. Know that it is in Australian Eastern Standard Time, because I do live in Melbourne, Australia. And then all you have to do is fill this out, submit it, and I will get back to you very, very shortly. So thank you guys a lot for watching, and I'll see you next time. Goodbye.